Hello there, young scientists. For today's session, we're going to be talking about gas laws. One of the most amazing things about gases is that despite their wide differences in chemical properties, all gases obey gas laws. Gas laws deals with how gases behave with respect to volume, pressure, temperature, and the Maam. The different laws that will be shown in this experiment will show the relationship of pressure, volume, and temperature. Let's start with the first law, Charles's law. This law is about the relationship of volume and temperature. Students will understand that volume and temperature are directly proportional with each other. For this experiment, we need the following materials: balloon, boiling water, and container filled with ice. Safety reminder, this experiment is considered non-hazardous, but you can use your gloves because the first part of the experiment, the setup is hot, and we should follow laboratory safety rules. I think you're ready. Let's start with the experiment.
First, blow up the balloon and tie it properly so that air will not escape. After that, fill the metal cookware with water and boil it. When the water is already boiling, place the balloon in the cookware with boiling water.
Now that the balloon is placed in hot water, let us observe what will happen.
Carefully transfer the balloon on the container filled with ice.
After transferring the balloon to the container filled with ice, let us observe what will happen.
Charles's law states that the temperature of an ideal gas is directly proportional to the volume it occupies if the pressure and mass remain constant within a closed system. In the experiment conducted, the balloon is filled with gaseous air. When the balloon is placed in the container with boiling water, the energy from the higher temperature water and steam molecules transfer to the lower temperature air molecules inside the balloon, exciting them. When the air molecules were excited due to the increase of temperature, they spread further apart, which increases the volume of space they take up. When the balloon was placed in the container with ice, there is transfer of energy in the form of heat from the warmer air molecules inside the balloon to the cold ice in the container. As energy is removed in the air molecules, they slow down, drop in temperature, and get closer to each other. This caused the balloon to decrease the volume of space they take up. The colder the air molecules get, the closer together they will be.
We can sum up Charles's law by stating that as temperature increases, volume increases as well. This makes it a direct relationship.
To understand the next gas law, Sir Bernard Lazaro will explain Boyle's law.
Hi everyone, on this video we're going to talk about Boyle's law. This simple activity is an excellent way to introduce students about the relationship of pressure and volume of an enclosed gas. The student will easily remember that pressure and volume are inversely related. In this case, we only need two materials. We need a syringe and a marshmallow. A safety reminder that this activity is considered as a non-hazardous. You just need to follow all normal laboratory procedures. With all that, let's get started. Before you proceed, make sure that you remove the end cap or the needle and keep it in a safe place. First step is to remove the plunger from the syringe and insert the marshmallow into the syringe. After that, Place back the plunger so the volume reading is approximately 8 ml mark, and then, after that, use your finger to seal the syringe. Or if needed, you can use a syringe tip cap to seal the syringe. So basically, no air can get in and out. What I'm gonna do is to push the plunger down and pull it back all while the air is trapped inside. I want you to observe what will happen. Alright, push the plunger down. And now, pull the plunger back. Boyle's law states that the absolute pressure exerted by an ideal gas is inversely proportional to the volume it occupies if the temperature and mass is remain constant within a closed system. In our experiment, when I press the plunger down, we increasing the pressure being placed on the air molecules inside by reducing its volume. As the pressure increases, the amount of force placed on our air molecules increases, and they are forced to closer and closer together, decreasing the volume of the space of that our gas takes up and shrinking the size of the marshmallows. While I'm pulling out the plunger, the volume of the syringe increases but the amount of gas remains constant because it is in a closed system. The pressure inside the syringe decreases. The lower pressure on the marshmallow causes its volume to increase according to Boyle's law. The expansion is due to the many trapped air bubbles like small internal balloons within the marshmallow that initially at atmospheric pressure. As the pressure of the syringe is reduced, the bubbles will expand to many times the original volume to equilibrate the pressure on either side of the bubble wall. Thus, as the pressure decreases, the volume increases in an inverse relationship. Next experiment, Maam Rica will show us about Gay-Lussac law of gas law. Let's watch her.
And now, we're going to perform another experiment which you can do also in your respective kitchens. This experiment is titled the Water Rising Experiment. In this, you'll be able to understand further the concepts of gas temperature, pressure, and volume relationship, and this time according to Gay-Lussac's law. So, let's do it. In this experiment, we need a transparent shallow dish, or you can also use a transparent shallow pan or plate, whichever is available. A water colored with food coloring, transparent glass jar, or you can also use a transparent drinking glass, candle, and lighter to light the candle. We have to use in this experiment colored water for us to easily observe changes in the water level if there will be. As well as we also have to use transparent materials such as this dish and jar made of glass for easy observations. Before we proceed, let me remind you of safety precautions when doing this experiment. First, do not ever play with lighter or matchstick or any other sources of fire or heat, for this material may cause you burns. Second, if you have skin allergies to food coloring, be careful not to spill it in your skin or in your clothes, for you may get stains from it. Also, be careful when using materials made of glass, such as this dish and jar, for if you break them accidentally, these materials may cause you wounds. Okay, the first thing to do is half fill the transparent shallow pan with colored water. Then, slowly and carefully light the candle using the lighter. And carefully place the lighted candle on the center of the transparent shallow dish with colored water. Then, carefully cover the lighted candle with the jar. Observe what will happen. What happened to the fire on the candle? Why did the fire slowly fade or disappears? What happened to the water as the fire faded? Why was there an increase in the level of water? Gay-Lussac's law states that the temperature and pressure of an ideal gas are directly proportional as long as the volume remains constant. When the jar was placed over the candle, the fire heats the air up. When the air is heated, the gas particles expand and move faster, putting pressure on the water. High temperature equals high air pressure. Again, according to Gay-Lussac's law, the pressure increases proportionately to temperature increase. Further, carbon dioxide, a product from chemical reaction, pushes oxygen downwards since it is hotter or less dense. As more carbon dioxide is produced, there is less oxygen available for combustion, causing the fire to fade. Fading of the fire lowers the temperature of the air, which causes less pressure on the water. The decrease in air pressure causes the water to rise. To sum it all, in Gay-Lussac's law, as temperature increases, pressure as well increases, and as temperature decreases, temperature also decreases at constant volume. Again, we performed experiments showcasing the three gas laws. First, according to Charles' law, the temperature and volume are directly proportional at constant pressure. Second, according to Boyle's law, volume and pressure are inversely proportional at constant temperature. And third, according to Gay-Lussac's law, temperature and pressure are directly proportional at constant volume. Thank you.